Good morning, everyone, and thank you for joining us in the Donaldson Virtual Classroom. Our topic today is long-term fuel storage, and our presenter is Matt Graham. And Matt, I'm going to turn it over to you.
Thanks, Lori. Good morning, everyone. Thanks for joining us today. And as Lori mentioned, our topic for today is long-term fuel storage. My name is Matt Graham. I'm the regional sales engineer, or a regional sales engineer with hydraulics and bulk fluid systems. Been with Donaldson for about 3 years, but have a fairly extensive past in the aftermarket parts industry as a whole. And for today, with our long-term fuel storage discussion, kind of the objectives that we're looking to kind of pass on and help everybody understand is really the differences between fuels of the past and today's ultra-low sulfur diesel and biodiesel, and what problems can arise in regards to how these fuels are stored long-term. Not so much, all the other things that go with it, but really focusing on, the storage application. And then what, if any, things can be done to prevent such issues from occurring. So with that, kind of the fuels of yesterday and today, really kind of break it down into three categories. The ultra-low sulfur diesel that we're all probably very familiar with now as kind of almost a global standard as where we can be. Biodiesel, and kind of what that brings to the table is, obviously a fuel that's made from some kind of biomass, whether it be, corn or vegetable oil or anything else. And then also kind of the pre-emissions fuels. You can see the images there. They kind of vary as their colors go, as kind of the cleaner, the more sulfur that we remove. All the way to the left would be your ultra-low sulfur diesel. So ultra-low sulfur diesel, what is it? As you can see from the image there, kind of, especially when it comes to kind of U.S. standards, but most of the globe is fairly within line as far as timeline goes. Before 93, kind of the sulfur level that was allowed was right around 5,000 parts per million. In 93, we went to a low sulfur diesel, and that moved to 500 parts per million. And then in 2006, 2007 timeframe was when ultra-low sulfur diesel started to really be kind of the mainstay and where things were going to be. This is all developed really from an emissions-based standard. The less sulfur that is in the fuel, the less of that byproduct is there, and the less pollution and that you end up getting coming out the tailpipe. When we remove that sulfur, it does a couple things that are, kind of on the negative side. The sulfur removing process removes a lot of the lubricity properties of that fuel, and you end up with some additional wear items on fuel systems. It's not so much just the actual sulfur portion as the lubricity. It's all the other chemicals that are, burned off and removed as a result of moving that sulfur. The process is called hydrodesulfurization, but you end up getting it much hotter, and you remove a lot of those properties that are there. So what we do to end up kind of putting that lubricity back into that fuel, so you're not getting, that additional wear item or wear on that, the best kind of additive is really to add biodiesel to that. Biodiesel has great lubricity properties, and a fuel supplier or blender or however it may be introduced can add up to about 5% of biodiesel to that ultra-low sulfur diesel, without actually really even reporting it. It's there as an additive. It's really not as that it's a bio blend. And then also as a portion of this, there's an increased cost. So as the diesel fuel is made at a refinery, it gets to the level of say that 5,000 parts per million. Well, then they need to take an extra step to get rid of that. So you do have an increased production cost. And one of the big things is sulfur acted as a natural biocide in that fuel, and also as an antioxidant. So with that sulfur in there, it would actually, prevent, any growth from happening inside the tank. It also would help keep that fuel keep that fuel from oxidizing and be able to stay in a natural state longer before it started degrading. So biodiesel. As we said, biodiesel can be up to a 5% mix without being reported. And biodiesel in itself is a whole other conversation, but when it comes to kind of the long-term fuel storage portion we're talking about, the big thing to point out is that biofuels have a higher affinity for water. They want to grab water out of the atmosphere, they want to pull it in, and it'll actually hold in solution in that fuel, much higher than your standard diesel will. Again, we said that, the reason it's there a lot of the times, even if you're not buying a bio blend, say, B10, B20, even B100, it's there a lot of times whether you think it is or not to help with those lubricity issues. One of the downsides of bio is that any exposure to air and heat leads to a pretty fast oxidization. Fuels kind of want to return to their pre-fuel state. And bio really wants to turn back to that state faster than a regular diesel will. And as you can kind of see here, if you're at the pump or anything like that, a lot of states, it kind of depends, but, you may not have really an idea of how much bio you're actually getting. If you're buying it in bulk, a lot of times you can dictate, where you want that level. But if it's not being reported, it might be something like this where, hey, this blend can have between 5 and 20%. So how fast do you know if that fuel is going to start degrading? It sometimes can be really hard to tell. Excuse me. So storing ultra-low sulfur diesel and biodiesel, kind of what happens as that fuel is stored? One of the things that can happen is microbial growth. That's really going to be a result of the water and air that is available to those microbes. And the second is oxidization. So fuel starts to break down, kind of revert back to its natural state. And that's going to be a result of temperature, air, and sunlight that's going to cause that effect. And you'll end up with a sludge buildup. As it oxidizes, you do also kind of change the chemistry of the fuel, so you get some acids that start to create corrosion and rust within the tank. And those are kind of the things that start to happen in that fuel mixture as a result of being stored. So the problems that actually, are caused because of that are as this. The microbial growth, what this does is degrades the fuel quality. Those microbes that are in there, they feed on that fuel. They eat the fuel. And as they eat that fuel, they produce waste, and that waste falls to the bottom. You can see kind of the diagram there on the right of what that kind of looks like, and kind of a real-life sample there on the left. And that biomass that's there starts to get pumped out of the tank, obviously. And, if you've ever been, in a situation where you've had a truck or a piece of equipment or something where, the filter gets plugged up and choked out, and you take it out and it's got kind of all this gooey, nasty stuff that's on it. That's that biomass that's gotten sucked up and pushed out to the piece of equipment. So it can plug those bulk and on-engine fuel filters really fast. And then we have the cost of fixing that problem. You may have been involved or have heard, shocking the system or, having the tank clean, things like that. If we just shock that system, and kill it, we can kill that, the microbial growth with a chemical. But the problem is if that water is still there in the bottom of it, okay, you got the waste of, all these bugs basically that fall to the bottom, that's still there. And if you've got water, that's just going to start back up again. So you're kind of on this roller coaster of, okay, we got to fix, and then it goes back. Really the only way to fix it is to have that tank completely clean, remove all of that out of there. It's almost like dandelions in your yard. Yes, you can, cut them off, and you don't see them, but in a week they're kind of back again because you haven't pulled, the root out of the ground. Kind of the same premises there with that microbial growth. On the oxidization side of the equation, again, it degrades the fuel quality. That fuel kind of, again, wants to revert back. And as a byproduct of that, it starts creating these varnishes. That's what you see in the lower image there. It's really sticky, tacky varnish, kind of, if you've ever actually varnished a piece of wood, it's kind of that same feeling that you end up having there. This causes tank degradation as well. You end up having that all over in the inside of tanks. It can get pulled out through a fuel pump and pushed into the fuel system, having to replace injector pumps, injectors, things like that. Excuse me. The net cost of fixing that problem is not cheap. And it really, again, cleaning the tank and kind of starting from scratch is the best way to do it. Varnish will start to create varnish and more and more, and really making sure that you get that tank clean and back to a square one is the best way to take care of that. So the question kind of comes to how long can you store it? Really, time is the enemy of fuel. Fuel degrades fairly slowly, but it is sped up by temperature and moisture. If you have fuel and say you put it in a mason jar and sealed it up and sat it there, and you kept it dark, it'd probably last for a long time and stay stable. But what happens is, no bulk tanks are actually sealed up completely. They're going to have vents. They need to breathe. And that air coming back and forth, one, starts to degrade it. If you just had a sample of fuel open sitting on a desk, you're going to end up, it's going to start to go bad over time. I'm sure we've maybe all seen it. You find a piece of equipment or something like that that hasn't been ran in 2 or 3 years, and you open it up, and the fuel portion looks nasty. The same thing's going on inside of that tank. But not only just that temperature in the air, but it's also the moisture. If that moisture gets in there and into that tank, it starts to rapidly speed that up. And it's worse almost for those bio blends than it is for just standard diesel. Again, we talked about the fact that biodiesel wants to grab moisture from the atmosphere, and the fact that there can be up to 5%, even if you think you're not buying a bio blend. So you pretty much have bio in there no matter what. It wants to grab onto that moisture. As that fuel kind of cools down at night, it releases that moisture back out, and you end up with actual water in the bottom of that tank. Also, at the same time, different temperatures can have an effect on it. You see kind of on the left there, the couple different temperature ranges. At about 68 degrees, fuel can be fine. This is without water, taking water out of the equation. It's passing, there's a test called the oxidative stability test. That's basically, how effective can that fuel still be burned at the level that it was supposed to. Below 80% is when that fuel is really going to start to produce those varnish particles and start to kind of grow that varnish. At 68 degrees, it's still okay for about after 6 months. But if we pull that temperature up to about, in the mid 70s, which is not out of line, it's really starting to degrade pretty quick after about 6 months. And even higher than that, say in the mid 80s, which again is not out of line for almost any part in North America, it's degraded pretty quick even after just 4 months. So that the degrading process happens in kind of that almost 6 months window that it starts, even if you're keeping your tank, relatively at a normal temperature. And if we add moisture to that equation, it really gets out of control fast. So what can we do to prevent it? What can be done to slow down that degradation? Really, today's fuel is going to start to degrade no matter what, even at the best conditions. There are a few steps can be taken to slow down that process. And really the number one thing you can do to prevent that from kind of getting out of control and degrading real fast and making it last as long as possible is going to be preventing that moisture that's in the tank. It really speeds up the oxidization process. It also introduces and allows microbial growth to start to occur. And the lower that we can get that moisture level to be at, the longer the fuel is going to resist that oxidization. And this can be kind of, done through a couple different measures. One, definitely keeping that tank as full as possible so you have the least amount of air in that headspace. But then also, you've probably seen this slide before in the past, but kind of the clean solutions approach, in this application, it's really focusing on that protect side of the equation, protecting that fuel. In long-term situations, We're talking, I've been speaking to a lot of folks lately who have been, purchasing large tanks because fuel is relatively inexpensive at this point, and they want to, buy that fuel and keep it for maybe next year's crop harvest in agriculture or whatever it may be. And they're going to be holding on to that fuel for a long time. So we're really not, talking about burning lots of fuel, going through a tank a week or something like that. Another big portion of the equation there, I guess, is the long-term fuel storage when we're talking about backup diesel generator applications. Whether it's hospitals, municipalities, I've seen a lot lately from data centers and places like that where they, have to have backup generators. They have to have that. They're usually, a large field of them. But again, they're not in a position where they're burning that fuel all the time, and that fuel sits there and it starts to degrade. Well, if we can protect that fuel and trying to keep that moisture out of there, that fuel is going to resist that degradation longer than if it's just left to the open environments. So the first would be adding a trap breather to the tank or reservoir if it's a backup gen set, and removing that moisture and dirt from the air before it can enter the tank. That tank, and again, we're not moving a whole lot of air because we're not, say, pumping out 200 to 300 gallons every, 5-10 minutes and going in a piece of equipment. We're holding on to it. But what happens is during the day, that tank heats up just from sunlight, and that tank the fuel's going to expand a little bit, that air is going to expand, and it's going to push and purge out some of that air. Well, on the intake cycle, basically when it starts to cool in the evening and overnight, you're going to pull in the air back through it. Even though the volume is not huge, again, like you're actually moving fuel and having to suck back in, but you still do have a definite air exchange that's there. And especially when it's pulling in that cool air at night, the humidity in that air is quite a bit higher. That air is thicker and you're pulling that in. And what happens, that gets into the tank, it cools a little bit further, it condenses, and that water ends up in the bottom of that tank. Now, what we can do to prevent that is instead of that kind of breather that you see there that has that kind of screen door type on it that's just preventing, birds and insects and stuff from flying in there, is we, remove that and add a trap breather. And what this is going to do is to, on that intake cycle, making sure that air does not have any moisture in it. So any air that's coming in is going to be dry. And it's really one of the best ways to extend the life of fuel, making sure that any air that's in that headspace does not have an abundance of moisture in it, which allows, again, that microbial growth to start happening and that fuel to oxidize faster. One of the next best, and I would actually sometimes put this in front of a trap breather, definitely using them in conjunction together, but not everybody has compressed air available. But a reservoir air dryer is a fantastic tool to be able to really lower the amount of moisture that can be in that system, and we're using a very small amount of volume. And I definitely bring this up because a lot of backup genset applications, like we said, hospitals, data centers, places like that, a lot of times they do have compressed air around, maybe not necessarily for that, but it's around and available in the building. And we can rob just a very small amount of air, about a half a CFM, and we flow that clean, dry air over the headspace of that tank. And what that does, that reservoir air dryer reduces the dew point by about 150 degrees. And as that air comes over the cross, the top of that headspace, what it does is that moisture wants to go to wherever the driest point is. So it's going to be very attracted to that dry air. So you see here kind of on the graph, you have your normal tank just sitting there. You do have humid air. You have the oil or the fuel is kind of saturated with water. It's hanging out in there. If we start to purge that tank with very, very dry air, that headspace that's there, you're going to get rid of all any moisture that's there, and it's going to be purged out of the tank. Second, what starts to happen is those moisture and those water molecules start to come out through the fuel. Whether it's free water, dissolved water, it's going to pull out. It's going to be attracted to that dry air, and it's going to get pushed out through the top of that tank. And what your result is that image there on the far right is very dry, very, very dehydrated fuel. And what that does is it chokes out any and doesn't allow any microbial growth to happen. So you also, at the same time, then are preventing that oxidization of that fuel. It can be a very powerful tool when trying to combat moisture in a bulk or long-term fuel storage, especially in those backup power generation sets. Then also mention outlet fuel filtration. We're talking about microbial particles, right? They're very, very, very small. Even, the biomass that's left behind as a result of what they're eating and feeding on, those particles will be very small. Even though we do see them, say when you do have a clogged filter, you can see them physically. It's because there's, hundreds of thousands of them all clumped together, but the particles are small. Your standard bulk filtration that may be on a tank, your 10, 20, 30 micron applications are really not tight enough and not efficient enough to be able to pull all that out. If we add tight, high efficiency filtration, on the outlet of that tank, or say in between the day tank and the generator set before it actually goes to the onboard applications, what we're able to do is prevent any of that microbial growth and those particles and stuff that's in that tank that may be occurring from entering the piece of equipment. The worst thing is to do is just to pass that off, have it be in the piece of equipment, and then you have downtime out in the field. You maybe have a generator that doesn't work quite right. Whatever the scenario might be, it's much easier and much more economical to tackle that problem at the tank than it is out on pieces of equipment. And the same really goes for that moisture prevention as well. Shocking that tank and trying to remove those microbial particles and all the biomass that's left behind, that's expensive. Yes, you can clean that out, you can turn the tank, and you can keep doing that type of things with like fuel cleaners, but it's real cheaper, real more inexpensive, and much easier to prevent those issues from happening with a breather than it is to try to clean them up afterwards. So kind of the main points, and to kind of wrap up here, is today's ultra low sulfur diesel and biodiesels are quite a bit different from the fuels from before. And one of the biggest things is the removal of that sulfur. With the removal of that sulfur, we got rid of, as making that happen or getting rid of that, we get rid of a lot of the lubricity properties, but we also get rid of that antioxidant that was in the fuel that stunted microbial growth from happening and helped that fuel maintain its quality for longer periods of time. Microbial growth and oxidization are what causes good fuel to go bad. Again, there's not much that you can, fuel is going to oxidize no matter what, just sitting there, but keeping it cool, keeping it dry is what's really going to increase the life of that fuel. If you have two fuel samples, one's clean and dry, and it's cool and it's not being beat on by the sun, and you have another one that is just let this sit out there, it's open to the atmosphere. The one that's open to the atmosphere and getting the moisture in there is the one that's really going to degrade fast. And the way that we can prevent these things from happening is really adding a trap breather to the tanks, polishing that fuel in the outlet, and if you do have compressed air that's available, adding a reservoir air dryer is really one of the best tools that you can use to prevent this stuff from happening and really increase the life of that fuel. A couple of resources to mention. The Donaldson.com webpage is really your access to anything that's Donaldson, whether it be bulk fuels, engine, hydraulics, whatever it may be. But I also want to point out mycleandiesel.com. It's really everything that we've learned about fuels in the last 15 to 20 years. Whether it be, specifically on biodiesel and what you can do with that, this topic of long-term fuel storage, there's hydraulic applications there as well, many different things that are there. But then also to point out is the mycleandiesel.com/survey website. This can be accessed by your phone. That's probably the most common place where people are on it. But if you're at a tank, or if you're, in maybe places that have generator sets or something like that, and you think you might be able to, put something together for this in order to, help solve a problem or to keep combating, microbial growth, and they're constantly replacing parts as a result of bad fuel. open this up while you're there. It asks you a few questions just about tank size and pumps, but as well, it allows you to upload a few pictures. That comes into us. We're able to go through that and kind of get back with you of here's what we would recommend for this. Really kind of takes, the thinking portion of the equation, it lets you lean on us to be able to help configure a system that would probably work best in that application. That's what I have on long-term fuel solutions, storage solutions. I'd like to open it up to any questions that anybody may have. Also on the screen is the contact information for myself. I cover kind of the north and west regions, and as well as Nick Rowe, my counterpart, covering the east and south regions. Again, with that, I'd like to open up with any questions.
Hey, Matt, it's Tom Hellier. Great presentation. Got a question for you.
Yes, sir.
Regarding what we're looking at in the future. So I'm old enough to remember when lead was removed from gas for gasoline applications, and some of the issues that resulted in with reference to lubricity properties.
Yes.
And how it reacted with valves and things of that nature. So we obviously moved on to ultra low sulfur diesel, where we moved the sulfur out, and we had the same lubricity questions, so we introduced biodiesel to handle that. And now that's brought on a whole other set of issues. So what we see in the future from petroleum manufacturers, do we see them stepping up and saying, you know what, that's created kind of a headache, so we're going to make an adjustment to how the fuel's refined, and we're going to start using this in the refining process, or at some point in the process, and remove the biofuel addition out of the equation to prevent this from happening? Or are they going to leave it to the problem to be solved downstream, like Donaldson's doing, solving it downstream? Do you have any information relative to that?
A little bit, just from reading and such. So I mean, additives. One, I don't think biodiesel is going away. It is a cheap kind of alternative. There's the environmental portions around it that people like to see as well. There are ways that the refineries could add lubricity. I mean, there's non-bio lubricity additives that are out there that you can add to fuel. They're just not as cheap as bio is. They could add those at the refinery level, but the thing is, the pipes and the infrastructure that's delivering the fuels from the refinery are the same pipes that also haul the jet fuel from point A to point B, and you can't have those additives kind of floating around still in the pipe when jet fuel comes through. You can't have any of that. So the additive and the mixing comes on, the next person down the stream from the refinery is who blends that fuel. So that's when it gets added in. And, yes, you can get, additives, again, that don't have bio. I don't think it's going away. And it can be an economical portion as well, kind of as a performance thing. I don't see it going away. And I think that there's, it's just going to be lots of different solutions that are out there to try to fight it until kind of everybody really gets on the same board. The best way that we've found to combat it really is that making sure that the moisture is not in that system. That's going to be what tears it apart at the end of the day.
Interesting. Thanks. Hey, just
I
one
know
last
it's not an answer, but
no. Well, it is. It's left to the hands of Donaldson, our customers, to treat with downstream for now until something better comes along. So,
right.
So you had mentioned oxidation of fuel and how that kind of returns it to a prior condition. So is it fair to say that oxidation is basically fuel transforming back to a pre-refined state?
In simple terms, yes, that's how I like to describe it. There's a lot more going on there at a chemistry level, and it gets really deep into really what's happening. But the best way I like to explain it is, that's what it's trying to do is revert back to where it was. And without, so that sulfur was kind of an antioxidant that kind of prevented that from happening. And when you add that oxygen to the equation, it basically wants them, might be a little too deep, but it wants to knock off certain electrons off of things, and it starts degrading, and it starts this kind of chain reaction. For lack of real deep dive, it's trying to revert back into crude oil, I guess.
Yeah. Hey, thanks again. Great job.
Thanks. Anybody else out there have any questions, comments, concerns?
If there's no more questions, please take note of the contact information on the screen right now, and please reach out to your regional sales engineer if you do have further questions. And with that, everybody have a great day. Thank you very much.
Thanks, everyone. Appreciate it.
Thank you.